Hello, and welcome to the first episode of Science Saturdays with Noah. I'm your host, Noah Mugen. I've loved science for as long as I can remember. I wanted to be a paleontologist when I was younger, and right now I'm actually looking to be a physicist. And I hope that through these videos, I can share that love of science with all of you. These Science Saturdays with Noah, these weekly videos, will each cover a different scientific topic. As we get closer to the holidays, they will focus more on winter-themed ideas. However, this week, in keeping with this outer space theme, we're going to be covering one of the most mystical aspects of science known to humankind: space and what's in it. Now, speaking of experiments, I'm going to quickly go over the materials that you're going to need for our activity today. Now, don't worry, they're common household items, and if you don't have all of them, you can easily still follow along with the experiment and see what's going on. They include a meter stick, or another way to measure stuff, but I prefer meter stick, a sharpie, a small balloon, a large bowl, bag of marshmallows, small ones, and a good amount of water. Everything that we know about, well, anything, comes from inside the universe. The universe is the dimensional space containing everything and anything you can imagine. You, your cat, some galaxy 3 billion light years away, they're all contained inside the universe. The universe used to be a lot smaller. In fact, it was so small that it was contained within an infinitesimally small dot known as a singularity. You know how hard it is to close an overpacked suitcase? How much energy it takes to push everything down so that you can close it? Now, imagine if you're trying to put a mountain in there. How much more energy would it take to close it? What if you're trying to put a whole galaxy in there? That would take even more energy. Well, what if you were trying to just put everything in the universe in this suitcase? I don't think you could do that, but that'd be a lot of energy. Now imagine if you were trying to pack everything within an infinitesimally small dot. That would take a lot of energy, and all that energy would be contained within a single point. And once that energy is released, the universe is going to start expanding rapidly. Now we're going to visualize that expansion in two different ways. First off, you're going to want to grab your bowl, your marshmallows, and your water. First off, you're going to place a handful of marshmallows inside the bowl and clump them together. See how tightly packed they are? That was before the universe started expanding. Now, just add a little bit of water and stir it up a little bit. See how the marshmallows have kind of moved around? As the universe expands and the surface that they're on expands, everything moves apart. In our universe, as our universe expands, the galaxies and galaxy clusters move apart from one another. Now add some more water. You see how even though many of the marshmallows are moving apart, they're still clumping together? That's gravity. In our universe, stuff sticks together even though the universe is expanding, because gravity between objects pulls them closer to one another, like in galaxies, and solar systems, like our sun. It's only the large things that are actually pulled apart, known as galaxy clusters, where gravity is not able to overcome the expansion in the universe. So these would be some galaxies and such. Now let's add some more water. The universe just keeps expanding, faster and faster. Stir it up again. Let's get moved around so that they're freshly scattered. and just keep on expanding that universe. They're gonna want to go to the edges of the bowl, not because this is a part of the universe, just because it's in the glass bowl. So you're just gonna wanna, stir it around, move them around. See how much farther apart these things are than at the beginning? Our universe expands faster and faster. And as it does, the objects in the universe move apart faster and faster. Sometimes forces like gravity can keep them together, but over time, everything just moves away. Now we're going to show this phenomenon again, but from a different way. For this one, all you're going to need is a balloon and a Sharpie. On the balloon, you're going to want to grab your Sharpie and just draw little dots all over it. These dots are going to represent things in our universe. See how all the dots are fairly close together right now? Again, that's before the universe started expanding. Now, you're gonna get your balloon, and you may have some way to blow air into it externally, but I'm just gonna use my mouth. You're gonna blow it up a little bit. See how everything suddenly moved apart? Just as the universe expands, everything in it moves away from one another. Remember the marshmallows. As the water surface expands, they're going to move away from one another. Now look again. Everything just keeps moving away from one another as the surface of the balloon expands. If you want, you can draw a few more dots on it. Add some more stuff. Solar systems are going to form. Matter's going to clump together. And that too is going to eventually move away. Now get it? And make it even bigger. Even the stuff that we just added is a lot farther apart from its friends and everything else. Remember, the universe expands, and as such, the distance between stuff expands with it, and everything is pushed away from one another. That's just the nature of the universe. And the universe has been expanding for a long time, and as such, it is really, really big by this point. We can't even comprehend how big the universe is, but we can try and use models and relative understandings to get an idea. For this next experiment, you're gonna want to grab a meter stick and some marshmallows. You see this marshmallow? Let's say that the width of this marshmallow is the distance it takes for someone to travel around the entire Earth. That is really far. It takes a plane to go that far, about 45 hours. Now it's about a centimeter. So you're going to place this marshmallow on the ground. If a centimeter is the distance it takes to get all the way around the Earth, then you're going to want to measure 9.5 centimeters away from it and place another marshmallow right there. That's the distance that it takes to get to the moon. And remember, this is just how far you need to go to get all the way around the Earth. The moon is a lot farther out than we like to think. Now from the original marshmallow, you're going to want to measure 3,720 centimeters away. That's equal to 37.2 meters. All the way over here, this is how far it would take you to get to the sun if the Earth's circumference is just 1 centimeter. This is really far away. It takes light, the fastest thing in the universe, around 500 seconds to get all the way over here. It is really far. And this is only within the tiny confines of our super small solar system. By this scale, the closest star, Alpha Centauri, would be 10,000 kilometers away. That's a quarter of the distance around our Earth. And even that is infinitesimally small compared to the vast reaches of the universe. As humans, we physically just can't comprehend how astronomically big our universe is. Humans really are just one tiny part of an insanely astronomically enormous system. I think that's pretty crazy, but also beautiful, don't you? Well, that wraps up another Science Saturday. I had fun, and I hope you did too. Make sure to tune next week for another fun activity. Bye-bye!